Stripping shader variants. How to cut build times and memory usage. Hello and welcome to episode number 9 of the Unity Performance Task Force podcast. I'm your host, Ruben from TheGameDev.Guru, and as usual, I'll kick things off with a question for you. Have you ever sat through a 20-minute build just watching the progress bar crawl, only to discover that most of that time went to compiling shader variants you don't even use? Or maybe your game's first load takes forever. The profiler shows 100 megabytes eaten by shaders, and you have no idea where all those variants came from in the first place. Sounds familiar? If so, this episode is for you. Today we're talking about shader variant stripping, one of my favorite performance levers. And honestly, I say that about every topic, so don't hold me to it. But here's the thing. Shader variants are sneaky. You think you're using one standard shader. Unity thinks you're using 47 variants of that shader, and it compiles every single one of them. That explosion kills 4 critical metrics. First, compilation time. I've seen builds balloon past 20 minutes purely because of shader variants. Your iteration loop grinds to a halt. Second, loading time. Unity might defer compilation to runtime, which means your players sit on a loading screen while the driver compiles shaders on the fly. Not a great first impression. Third, memory usage. More shader variants means more memory. 100 megabytes is not unusual if you let variants run wild. Fourth, draw call cost. If you accidentally use multiple variants of the same shader across different materials, say one with normal maps, one without, the GPU has to switch shaders between draw calls. That switching is expensive and it murders batching efficiency. So why not let Unity strip variants automatically? Good question. Unity tries, but it doesn't always know what you need ahead of time. If you rely purely on automatic stripping, you'll still end up with variants you never intended to ship. Manual stripping, or at least complementary manual stripping, gives you surgical control. So what exactly is shader variant stripping? Simple. It's removing the shader variants you don't need before they make it into your build. Here's the mental model. You create a material using the standard shader. You think that's one shader. Unity compiles dozens of variants depending on which features you enable. Normal maps on? That's a variant. Normal maps off? Different variant. Ambient occlusion enabled? Another variant. Point lights, spotlights, directional lights. Each combination spawns a new variant. If your scene uses materials with different feature combinations, you end up with multiple variants in memory, and switching between them at runtime costs GPU cycles. The goal: identify the variants you actually need and strip everything else. What should you strip? Everything you don't need. Start with shaders that have invalid code paths, though Unity usually catches those automatically. Next, debugging configurations. If you use multi-compile directives for debug versus release modes, strip the debug variants in your final build. Then, unused features. Don't need ambient occlusion? Strip that keyword. Don't use normal maps on certain shaders? Strip the normal map variants. The inverse also works. If you only use shaders with normal maps, strip the variants without them. Lighting modes are another big one. Shaders often generate variants for spotlights, point lights, and directional lights, even if you only use one type. Strip the rest. The general workflow is 3 steps. Step 1. Find the shader variants you want to keep, or the ones you want to remove. You can build a whitelist or a blacklist. For extreme control, I recommend a whitelist. That way, you only include variants you explicitly approve. Step 2. Remove the other subset using Unity's scripting API or a plugin. Step 3. Test the visuals on your target device, because Unity might surprise you, sometimes in good ways, sometimes not. Let me walk you through the practical workflow. Imagine you have a scene with several objects, all using the standard shader. Some materials have an occlusion map assigned, others don't. That creates multiple shader variants under the hood, and switching between them at runtime thanks batching. How do you find out which variants Unity is compiling? Option 1. Select the shader in the project window, click Show in the inspector, and Unity will list the variants. But this isn't reliable, because Unity doesn't always know which variants you're using until you actually run the game on a device. Option 2, the better option. Go to Player Settings, Graphics, and enable Log Shader Compilation. Then build and run on your target device. Unity will write every shader variant it compiles to the player log, including the exact keywords for each variant. On Windows, the log lives in app data, local low, company name, project name, player.log. Open that file, and you'll see lines like compiled shader, standard, keywords underscore normal map underscore occlusion map. That's your smoking gun. Now you know exactly which keywords are active. Here's a detail most people miss. Unity compiles shaders to an intermediate language at build time, but the final compilation happens on the device. The driver has to translate that intermediate representation into machine code specific to the GPU. Both stages take time, so reducing variant count speeds up both your build and your runtime. Now let's say you want to remove the occlusion map variant. You've decided that feature isn't worth the cost. First, confirm the keyword. Search the player log for occlusion. You'll find lines referencing underscore exclusion map. That's the keyword you need to strip. Here's how you do it with the scripting API. Create a new script in an editor folder. Name it something like shader stripper. It doesn't need to be a mono behavior, make it a plain C# class, but it does need to implement the IPreprocessShaders interface. That interface has one method, onProcessShader. Unity calls this method at build time for every shader variant it's about to compile. Your job is to tell Unity which variants to skip. The method receives a list of shader compiler data. Each entry represents one shader variant. Iterate over that list. I like to loop backwards when removing items from a list, so start at count -1 and decrement. For each variant, check the keyword set. Unity provides a method called isEnabled that checks whether a specific keyword is active. But here's the trick. Shader keywords come in two flavors, global and local. Global keywords apply across all shaders. Local keywords are specific to one shader. The occlusion map keyword is local. You can confirm this by selecting the shader in the project window and opening the keyword dropdown. Unity will list global and local keywords separately. To check a local keyword, create a new shader keyword object, passing the shader reference and the keyword name, in this case underscore exclusion map. Then call isEnabled on the variant's keyword set. If it returns true, call shader compiler data.removeAt, passing the current index. Optionally, log a message so you can verify that stripping is happening. Save the script. Unity will now invoke it during every build. Now, build your project again and check the player log. Search for exclusion. No results. The variants are gone. What happens visually? You might expect pink materials, the classic shader missing error. But Unity is smarter than that. It falls back to a similar shader that doesn't support occlusion maps. Your scene still renders, but the dark ambient occlusion lines are gone. Personally, I'd prefer to see pink materials because that tells me something unexpected happened. If I assigned an occlusion map texture, I'd expect to see it in the game. A silent fallback can hide bugs, but that's how Unity handles it. In the console, you'll see a count of how many variants were stripped. In a real project, that number can be substantial, dozens or even hundreds of variants. So when should you use shader variance stripping? Use it when you have long iteration times. If your builds take 10, 15, 20 minutes, shader variants are often the culprit. Use it when you have high memory usage and need to reclaim those megabytes. Use it when you're seeing expensive draw calls and you suspect shader switching is to blame. The deeper benefit is awareness. Once you start logging shader compilation, you'll see exactly which variants Unity is generating. That awareness alone is valuable. You'll spot redundant features, forgotten keywords, and surprising combinations. Then you can decide which variants to keep and enforce that decision through stripping. When should you avoid shader variant stripping? When you don't need it. This can be a time sink. Getting the whitelist or blacklist exactly right takes iteration and testing. If your builds are fast, your memory is fine, and your draw calls are cheap, don't invest the time. But here's the nuance. Technically, it's always a good idea to strip unused variants. You'll get faster builds, smaller memory footprint, and cheaper draw calls for free. The question is whether the time investment is worth it for your project right now. You need to evaluate the trade-off based on your team's varieties and your performance budget. Let me recap the key points. Shader variant stripping makes you aware of all the shader variants Unity is compiling under the hood. What you see in the inspector is not what you get. Unity generates variants based on material settings, lighting configurations, and feature keywords. More shader variants means longer compile times, longer loading times, higher memory usage, and more expensive draw calls. The workflow is straightforward. First, find the shader variants you want to keep or remove. Use the player log with log shader compilation enabled to see the exact keywords. Second, create a script that implements IPreprocessShaders and removes unwanted variants in the onProcessShader method. Third, build and test the visuals on your target device because Unity might fall back to a different shader and you want to confirm the result matches your expectations. Shader variant stripping is one of those quiet wins. It doesn't require new tools or hardware. It's pure workflow discipline. You identify what you need, strip what you don't, and your build pipeline gets leaner and faster. If you found this podcast episode useful, you can access in-depth lessons in the Unity Performance Task Force program at www.performancetaskforce.com. And if Unity Consulting is what you are after, book a free discovery call at https://consulting.TheGameDev.Guru. Till next time.